DNS is the reason you can type google.com instead of remembering an IP address. But here's the problem. Most people think DNS is just a lookup. Even many developers think that. It's not. DNS is a distributed system with memory, delegation, and rules. And if you misunderstand it, debugging anything network-related becomes unnecessarily painful. Let's simplify the story first. You ask, where is google.com? Your system doesn't go straight to Google. It asks someone whose job is, go find the answer and come back. That someone is a recursive resolver. If it doesn't already know the answer, it starts asking the internet step by step. Who handles .com? Who handles google.com? What's the IP for this name? It gets the answer, remembers it, and gives it back to you. That's the whole journey. Now let's make it actually make sense. The reason this works at global scale is one idea: delegation. No single system knows everything. Instead, the root knows where .com lives, .com knows who handles google.com, google.com's name servers know the real answer. Each layer only knows who is responsible next, not the final answer. That's the trick. DNS scales because it passes responsibility, not because it stores everything. Now here's where most developers quietly get it wrong. They mix up who finds the answer and who owns the answer. A recursive resolver is the one doing the searching. An authoritative server is the one giving the final answer. One chases, one knows. And if you confuse these two, DNS stops making sense very quickly. Now let's talk about something that explains 80% of real-world confusion. DNS does not just answer, it remembers. Every answer comes with a TTL, time to live. That tells resolvers, you can reuse this answer for this long. So when you change a DNS record, the internet is not updating everywhere. Different resolvers are just holding old answers until their TTL expires. That's what people call DNS propagation. It's mostly just cache expiry. And here's the part that really trips people up. DNS also remembers failures. If a resolver asks, does this domain exist? And the answer is no, it can cache that too. So even after you fix the issue, some users may still see failures because their resolver is remembering that earlier no. That's called negative caching, and it's why DNS can feel inconsistent across devices and locations. Now layer one more reality on top. Different people are often using different resolvers. Your laptop, your phone, your office network, they might all ask different systems. Each one has different cached answers, different expiry times, different memory of failures. So when someone says, it works for me, and someone else says, it's broken, both can be right. DNS is not inconsistent. It's distributed memory behaving exactly as designed. Let's ground this with the records you actually use. A to name to IPv4 address. AAAA or Quad A record to IPv6 address. CNAME or canonical name to one name is an alias of another. It maps one domain name to another, and that second name is what ultimately resolves to the IP address. This lets your domain delegate resolution, so you're not tied to specific IPs. NS or name server, which name servers are authoritative for the domain. MX, where email should go. TXT, metadata, verification, security configs. And one subtle thing, example.com and www.example.com are two different DNS names. In a typical setup, the root domain, example.com, is the apex and points directly to an IP using A or Quad A records. The www subdomain is often configured as a CNAME that points back to example.com in its CNAME record. This is a common pattern, but not a requirement. Both names can be configured independently and even point to the same IP using separate A or Quad A records, but it usually is not ideal. They usually behave the same because someone configured them that way, but DNS treats them as completely separate entries. Now, two things even many engineers casually get wrong. First, DNS is not just UDP. Modern DNS requires proper TCP support too. Second, DNS SEC, or DNS security extensions, does not hide your queries. DNS SEC adds authenticity and integrity. It helps verify that the DNS answer is real by adding secure cryptographic signatures to the DNS records for verification. But it does not encrypt what you asked for. So DNS security is about trusting the answer, not hiding the question. So here's the real picture. DNS is not just a lookup. It's a system where responsibility is delegated, answers are cached, failures are cached too. Different resolvers remember different things, and correctness depends on both logic and memory, which is why DNS feels effortless when it works, and not so effortless when it doesn't. Follow NeatStack for more such videos.